Welcome to today's lecture session. I'm Comfort, an industry guest lecturer. Today, we're diving into maintenance planning. Why is this so critical for electrical engineers? Because our world runs on reliable power. We'll focus on the backbone of our electrical infrastructure, vital equipment like power generators, industrial motors, and transformers. We'll explore how strategic planning keeps these systems running reliably and safely, preventing the kinds of failures that can halt an entire operation. By the end of this lecture, you'll be able to confidently define maintenance planning and articulate its importance. We'll identify different maintenance types, from preventative to predictive, and learn to evaluate real-world strategies. Most importantly, you'll see how planning is the first line of defense against costly failures. An unexpected transformer failure can cause a citywide blackout, costing millions and creating significant public safety risks. Our goal is to learn how to prevent that. So, what is maintenance planning? It's the proactive process of deciding in advance what work needs to be done, why, when, and how. Think of it like drawing a map before a journey. For an electrical engineer, this means planning for a critical industrial motor. We decide to inspect the bearings and windings. We determine to prevent overheating. We schedule during a planned factory shutdown to avoid disrupting production. And we define using specific tools and following precise safety protocols. Without a plan, maintenance becomes reactive or firefighting, leading to sudden breakdowns, safety hazards, and much higher costs. Imagine a hospital's critical backup generator failing during a power outage. It's a frantic scramble to diagnose the problem under pressure. Essential replacement parts may not be on hand, and every moment of downtime increases risk. This reactive chaos is not only incredibly stressful, but also far more expensive than planned preventative work. The objectives are clear. Ensure equipment availability, optimize resources, and reduce downtime. But the importance goes further. Maintenance planning improves safety, prevents accidents, reduces risks, and extends the life of expensive assets. For industries like power plants, telecom, and manufacturing, this is not optional. It's survival. There are different types of planning: preventive, predictive, corrective, and shutdown. Planned maintenance is systematic, cost-effective, and avoids surprises. Unplanned maintenance? That's when a machine suddenly fails, production halts, and the emergency costs skyrocket. A clear difference. So how do engineers actually plan? It begins with a structured process. Step 1. Identify the need, perhaps from a thermal scan showing a transformer is overheating. Step 2. Prioritize. A failing backup generator for a hospital is more critical than a non-essential motor. Step 3. Estimate resources, the right technicians, specialized tools, and specific spare parts. This initial phase is all about understanding the problem and what it will take to solve it. Next, step 4 is scheduling strategically, like planning switchgear maintenance during a factory shutdown to avoid downtime. Step 5 is assigning clear responsibilities, ensuring a certified electrician handles high-voltage work. And step 6 is to monitor and improve. After a job, the team reviews the outcome to refine future plans. This transforms planning from a one-time task into a continuous improvement cycle. To manage this complexity, modern organizations use computerized maintenance management systems, or CMMS. This software is the central hub for organizing tasks, tracking the service history of equipment like generators, and managing spare parts. They help sync maintenance with production schedules and enforce the use of standardized safety checklists. This proactive, data-driven strategy is what keeps engineers a step ahead, turning maintenance from a reactive chore into a strategic advantage that ensures reliability and safety. Let's consider a real-world case study. Imagine a large power generation facility. During annual maintenance planning, the team deprioritized servicing a primary generator's cooling system to save time. They assumed it was low risk. Months later, a critical coolant pump failed, causing the generator to rapidly overheat, damaging its windings and bearings. The unit tripped offline, triggering an emergency plant-wide shutdown that cost millions in lost revenue and emergency repairs. The lesson is crystal clear. Skipping proactive planning costs exponentially more than the planning itself. The planned cost of servicing that pump was a few $1,000s. The cost of failure was catastrophic. This principle holds true for a high-voltage transformer or a critical industrial motor. A simple planned oil analysis for a transformer is a tiny investment compared to the millions required to replace it after a failure. So, to summarize the core pillars. First, planning ensures safety. Planned shutdowns prevent catastrophic failures, like an arc flash from a neglected switchgear, protecting your people. Second, it guarantees reliability. Proactively servicing a motor or generator ensures they perform when demand is highest. And third, it delivers profound cost savings. You're trading a small, predictable expense for the prevention of massive, unpredictable losses. It's a continuous cycle of planning, executing, analyzing, and improving. As you move forward, reflect on these critical questions. Why is meticulous planning so fundamental to a successful preventive maintenance program? How can you, as an engineer, effectively argue the case for investing in reliability when faced with pressure to cut costs? And what are the real-world challenges organizations face when implementing these plans? Ponder these questions. Your ability to navigate these strategic challenges is what will elevate you from a good engineer to a great one. Thank you for your attention. I look forward to seeing you in our next session.